Hey everyone, welcome back to the Methods 2017 Exam 1, and this video is going to be focusing on question 8b. Now this one tells us to find the probability of A complement intersection B complement in terms of P. Now the first thing I've done is I've written down some information from the previous question, such as the probability of A given B is 1 over 5 and the probability of A is equal to 4p. These are both things that were either told in the previous question or we found out in the previous question. Now, if I write this, the probability of A given B, as the probability of A intersection B divided by the probability of B, it's going to make things a bit easier as we'll be able to find the probability of B, because we know that the probability of A given B, which is also equal to the probability of A intersection B divided by the probability of B, is equal to 1 over 5. Now, if we multiply both sides by the probability of B, we're going to get this. And we know that the probability of A intersection B is just P. That's what the previous part of the question said. So we get P equals the probability of B divided by 5. So the probability of B is equal to 5p. And this is going to be very important. The next thing we're going to do is we're going to draw a corner map. So this is going to help us find the probability of A complement intersection B complement. So here we're going to write A complement, B complement. And I'm going to write 1 here, and I'm going to explain why shortly. So this box is going to represent the probability of A intersection B. This box is going to represent the probability of A intersection not B, or A intersection B complement. This is going to represent the probability of A intersection B plus the probability of A intersection B complement, which is just the probability of A. This, similarly, is going to represent the probability of A complement. This is going to represent the probability of A complement intersection B complement, which is what we're trying to find. Now let's start filling in this table. The first thing we know is that the probability of A intersection B is P. The next thing we know is that the probability of A is 4p. Now if we think about it, the probability of A plus the probability of A complement has to add up to 1, which is why there's a 1 there. So if we do 4p, which is the probability of A, plus the probability of A complement, it has to add to 1. So the probability of A complement is 1 minus 4p. So we can fill this in. The next thing we know is that the probability of B is 5p. Using a similar logic, this is going to be 1 minus 5p. Now P plus the probability of A intersection B complement has to equal 4p. So basically, P plus whatever is in this box has to equal 4p. So we know that this box has to be 3p. Now P plus whatever's in this box has to equal 5p. So this box has to be 4p. Now the next thing we know is that 4p plus whatever's in this box has to equal 1 minus 4p. So 4p plus the probability of A complement intersection B complement has to equal 1 minus 4p. Now subtracting 4p from both sides will give us the probability of A complement intersection B complement is 1 minus 8p. Now you can also do this from another angle. You could add 3p plus whatever's in this box has to equal 1 minus 5p, and you would get the same exact result. And this is going to be our final answer. Thanks so much for watching.